Okay. All right. So let's start our lesson. So, by the way, what is your expression about the last lesson?
Yeah.
What is your practice about the last topic? And did you feel any difficulties?
I think yes.
Okay. If you find any problem difficult, send it to me via Telegram, and I will send feedback and my suggestion. Okay. We will discuss the problematic solutions in your home task later. Yeah. Today we will discuss about the new topic, which is surds. So you've seen such kind of formulas in your school, for example, like this: 3 and 7 power, and here 14, right? In your school, you've seen such kind of mathematical expressions, right?
Yeah.
Today we will discuss them. These all called surds. Okay, keep it in mind. In real life, you can use such kind of surds. For example, space exploration, you can use the surds. Why? Because you know the trigonometry. You know, in the trigonometry, you have these kind of expressions. For example, here you can see surds, right? Surds, because the value of the trigonometry functions is the surds. That's why you have to work with the surds, you know. And also in the real life, in nature, you can see also the natural objects that is the products of the mathematics, you know. For example, on the right side, you can see this one. What is this? Can you name it?
Shell? No.
Yes, this is shell. And the parts of the shell looks like this: square root 2, square root 3, square root 4, square root 5. You see?
Yeah.
And in mathematics, we can express like this. The shell can be expressed like this. Can you see? So, okay. And look at this one, the fisherman. And what is your idea about this fisherman? I mean the picture. What is the meaning of this picture? Can you tell me?
Like angles, degree.
Angles. Angles can be seen everywhere, you know? Here, you can see, right? So, for example, here's angle, here's also angle, here's angle, everywhere angle. And when angles exist, you can use trigonometry. When you use the trigonometry, you will receive the surds, you know, the surds. Okay, let's continue. This is our agenda. We will follow this outline. First of all, I will define the surds, and each part of the surds can be expressed with a strict name. You should have to know that. And secondly, we will rationalize the surds, you know. I will explain this mathematical operation. And then the third one, law of surds. We will we will learn a set of rules to apply mathematical problems. Okay. So, and then the fourth step, we will analyze a problem, a simple problem and a solution. Okay, you will learn how the techniques of solving the problems. And then we will do some practice. I will give you a few mathematical surd problems, and you will apply what you learned during this presentation into these problems. Okay, and I will suggest a learning platform on the sixth step. After that, I will assign you home task. Okay, let's define the third surds. So as you can see here, surds components has its own names. For example, degree. Okay, this 3 and this one. What is the degree of this root? Can you tell me?
So 3.
Yes. And what is the name of this?
Degree.
This radical sign. This is radical sign. This one. This one is radical sign. This one is degree, right?
Yeah.
And so what about this one? What do you call it?
Radicand.
Radicand, right? The whole thing. I mean this one is also called radical. You know, radical. As you can see here. And let's look at the right side. Quadratic surds. Quadratic surds, as you can see here, it looks like the first one is a real number, and then the second one is a rational number. You know, that is not the perfect square. You can't take the square of this number. This is the quadratic surds. You can see the examples also. Quadratic surds, it means the radical sign is equal to 2, you know? Radicals, when the radical sign is equal to 2, you call this kind of surds is quadratic surds. And the sum of the real number in surds is called mixed surd. This is mixed surd. You know the mixed fractions. For example, the 7 whole, so 3 divided by 5, for example. This is mixed fraction, for example, mixed fraction, because it has the whole number, real number, you know? You understand?
Yeah.
Okay, so let's continue. Now you understood the parts of these surds, right? Okay, so now let's make some practice so that we can identify what you learned. This one. Just quickly tell me the parts of the this surd, okay? Can you tell me the radical sign?
Radical sign?
Yes.
It's
what is the radical sign equal to? Of it. Radical sign. Look at this.
Yeah.
The radical sign is this expression, you know. What about the degree?
Degree 7.
Yes, degree 7. What about the radicand?
6.
6. Absolutely. Okay, you learned this, and let's go to the next presentation, which is about the rationalizing operation. When you rationalize the thirds, you will rationalize in the denominator. You know, you have a fraction a, b, and these two parts, I mean the above and below, has its own names. Example, this is called a denominator. Denominator. And a is called numerator. Numerator. Okay. So here, rationalizing the denominator, it means rationalizing the third, you know? Okay, let's analyze the below. You can see how we can rationalize the surds, you know? Okay, so look at this. You know, in the fractions, we have such kind of rule. If you multiply the fraction by the same number to both sides, for example, a multiply c, b multiply c, it's equal, it remains unchanged. Do you remember this rule? Now we're using this kind of rules. For example, we multiplying, you know, the 5 quadratic surds, you know, the quadratic surd under the, radicand is 5, and you multiplying this surd to the numerator and denominator. You know, keep this in your mind. If you multiply the same number of surds to the radical sign, I mean the degree. For example, the degree of this surd is equal to 3. It means if you multiply 3 times, for example, if you multiply 3 times the same surd, for example, we multiply 6 radicands and they multiply this one, the 6, and this becomes this one. 6 multiply 6 multiply 6, or 3 under root, you have 6, or this is equal to 6. Do you understand? Where did I take this 6?
Yeah.
The same technique is going here. I am multiplying the degree of the surd is equal to 2. This is quadratic surd. And I'm multiplying the same surd to the denominator so that I can take the real number. Okay, this is integer. You understand? This operation is called rationalizing the denominator. Rationalizing the denominator. Okay?
Yes.
So, and because you have to get rid of the root sign in the denominator. It's okay if you have root sign on the numerator, but it's not okay if you have root sign in the denominator. So here you can see also a simplification technique. So here's 18. 18 is 9 multiplied 2. You know, 9 is the square of 3. That's why you can take the 3 out of the root. You can see, and then you can multiply the same surd. I mean the quadratic surd of 2 radicand, and you can get rid of the square, I mean the root sign from the denominator. Okay, so simplifying this, and then the multiply top and bottom by square root under square root 2 to rationalize the denominator. Okay, so anything cancelled by 2. Correct. Understood this, right? And here also the second type of rationalizing operation, where you have surds on the numerator and the denominator, so just multiply by the conjugate in order to rationalize the denominator, so this is called conjugate. Learn this phrase. Okay, this is called conjugate. So to get rid of the root sign in the denominator, you have to multiply this fraction by the conjugate. Okay, learn this, keep this phrase in your mind, and your denominator shouldn't contain a surd. Okay, so the meaning of this rationalized operation is just getting rid of the root sign in the denominator. Okay, do you understand this operation?
In first expression, in answer we have quadratic sign 2, yes?
In the first.
No, under.
A.
Solution, in solution.
In solution, yes.
Yeah, we have,
yes.
Where is 2?
Where is 2?
Yeah.
We're canceling it, Can you see here? We cancel because we have the same number on the numerator and denominator. We canceling it.
I can multiply 3 and 2, get 6, and on top we have 2 and quadratic sign 2.
Yeah. So this, you can't multiply directly the 3 to the third, For example, here you have no third, but you have the third, Initially, you just separated this number into 2, 9 and 2. 9 is the square of the 3. That's why you take the 3 out of the square root. And you have 2 left under the square root. Yes?
Yeah.
You have to get rid of this quadratic third. Okay? To this, you have to multiply under square root 2 third. This is conjugate. Okay? So you multiplying this to the both sides. I have explained that 2 thirds equal to rational number. It's a real number. It's integer, Do you understand?
Yes.
That's why we get 2, but on the numerator, we have also 2. That's why I cancel this problem, cancel the 2 on the both sides. Do you understand?
Yes.
Any questions about this rationalizing operation?
No.
Okay, if you don't have, let's continue. Now we came to laws of thirds. Okay, the first one. You can multiply thirds each other, but you have to multiply the radicands. Okay? You can multiply the radicands. A multiply B. Okay? So if you multiply the same surds each other, their power increases, and you will have only one surge. Okay, like this. Okay, and you can multiply this expression as well each other. I mean, look at the surge rule. In front of the surge, you have real number, you have integer, right? And you can multiply these integers each other, and you can multiply the surds each other. Do you understand the combination?
Yeah.
So surds to surds and integer to integer. So when it comes to the division of surds, if you have surds on the numerator and denominator, you can take the surd of the fraction like this. This is force rule. And when it comes to this operation we've applied so far is used in the rationalization, you know, you multiplying the conjugate to the numerator and denominator. Understand this?
Yes.
Apply this rule in the rationalizing. And let's, here you can see also the numerator is not the surds, it's integer. And here numerator and denominator are the surds. In the past, you have surd on the numerator. This is the difference between fourth, fifth, and sixth rule. Okay, this is deuce. This is deuce. You have also don'ts as well. So you can see don'ts. You can subtract, you know, you can't add two surds each other. For example, you can do this operation. You can do this operation like 6. You can't do this. Okay, forget about it. There is no addition between the two surds, and you can't also subtract them like 7 minus the square minus 3. You can't do this. So, I mean, like 4. There is no such kind of operation, okay?
Yeah.
And also, you can't, this under square root, you can't have negative number, okay? I mean, you don't have such kind of expression like under square root, you have minus 4. Why? Because as you know, the multiplication of two number, for example, a multiply b equal to c, right? This is always positive, you know, positive. Why? For example, let's see the combination. 3 multiply 6, 80. For example, in minus 3 multiply 6.
Minus 18.
Yeah, minus 18. I am explaining with the two different numbers. But when it comes to the same numbers, for example, a multiply a equal to a square, right? For example, this one is 2 multiply 2 equal to a square, you know. But minus 2 and minus plus 2 is not equal, because this is minus number, this is, you know, negative number, this is positive number. It becomes b, you know, this one is a. So that's why if you multiply two negative number each other, you will also get the positive number, you know. That's what I mean. So the multiplication of two the same numbers are not equal to positive number. Keep this in your mind. That is why on the square root, you shouldn't have the negative numbers, okay? You will have also always positive numbers, but it's okay with the third degree roots, you know, for example, -7. It's okay. This is okay. It's always okay with the even degrees, you know, even degrees. Even degrees, it is, this is, for example, this one is even.
Yeah, 1, 3, 5.
3, 5, 3, 5, and 7, they are
7, 9.
degrees.
Yeah.
Yes, they are odd degrees. It's okay if you have a minus number under odd degree surds, you know, it's okay. But when it comes to the even numbers, I mean the even degrees, you shouldn't have, you know, positive, I mean the negative numbers under the root, you know, for example, this one. It's not right, okay? Keep this in your minds. You can multiply, you can take the fraction, you can also take the decimal numbers, you can divide this surds, but you can do this in addition, subtraction, and the negative numbers on the even degree surds. Do you understand?
Yeah.
Okay, let's continue. And here we have practical explanations of the surds. For example, here we will list them all and then explain each of them control. For example, here the three rules are explained here. Three rules are explained. So the first one here, look at the exponent, you know, this is exponential notation. Exponential notation, you know, it allows us to use the exponential laws. This rule is telling you that you can express the surds like exponents, you know. For example, the 3 degree surds under root, you have 7, you know. You can express these surds with as exponents, you know. Here you have 1 divided by 3. Do you understand? And you can also do the same with the surds as well, you know. If the you know, just let's zoom on this problem. Now you can see clearly, right?
Mm-hmm.
Look at this. Here, the degrees are the same. Not that n. In this case, you can take the radicands into one the same square, one the same root, you know. And here also, if the degrees are the same on the numerator and denominator, you can take or separate. Both of them are possible. Here you can see if you have exponent under the root, you can divide exponent by the degree of the surd. Do you understand this rule? For example, if you have 3 and 7 power, you can divide its power by 3, you know? So 2 divided by 3. Do you understand?
Yes.
Okay. So here's some examples I give provided to you. Look at the example. There's some example using this law. For example, 3 degree and the cube root. This is cube root. Multiply cube roots in the radicals, and the first radicand is 16. The second radicand is 14. If you can multiply both of them. If they are not the same, I mean, for example, 3 degree surds, under the roots you have 16, multiply 4 degree surd, 4. You can't multiply 16 to 4. Why? Because their degree are not the same. Okay, this one use it only when the degrees are the same. Here also you can see you multiply, but not that. If you multiply, uh, the radicands, you may have the roots. You may have a real number, because you can take the root of this number. Uh, you can't take the real number out of the root, because you will have a possible number that is rootable. Do you understand? Okay.
Yes.
So, and let's look at this. And also like, unlike, surds. Can you read it just out loud?
2 surds m degree root a and n degree root b are called like surds if m same as n. Otherwise, they're called unlike surds. For example, surd 2 and surd 3 are like surds. However, surd 2 and 3 degree surd 2 are unlikely surds. An important thing to realize about surd laws we have just learned is that the surds in the laws are all like surds. If you wish to use the surd laws or on unlike surds, then we must first convert them into like
Yes.
surds.
Yes. So, and this rule is some kind of magical. Why? Because you can change the degree of, surds. For example, here you've given 3 other roots and multiply. So 4th order roots. To multiply these two surds each other, you have to make both of the roots equal each other. How? So, can you find the
Yeah,
common, greatest
like
common
3 we
divisor?
should
Yeah,
3 we should multiply 4 and 4 we should multiply 3.
yeah. Greatest common multiple. Lowest common multiple. Lowest. In mathematics, you have such kind of operation. Lowest common multiple. By using the prime factorization, you can find the lowest common multiple, if you can remember. Lowest common multiple. So lowest common multiple for 3 and 4, for example, LCM for 3 and 4 is equal to 12.
Yes.
You remember this operation, lowest common multiple. This is called lowest common multiple because this number can be divisible by 3 and 4. And the 24 is also divisible by 3 and 4, but it's not the lowest.
Yes.
You understand? So
Uh-huh.
that's why we call this is lowest, and this is common, and this is multiple of 3 and 4. Keep this in your mind. So, and what about greatest common factor? Greatest common factor. Factor, it is divisor. Greatest common factor. For example, you are given 12 and 8. What is the common divisor for these numbers? For example, you can divide this number by 2. This is also divisible by 2. And
Yes.
this one is divisible by 4 as well. This one is also divisible by 4. What about the greatest number? What about the highest number? You can call this also highest. Highest.
For 12, it's 6.
No, I'm not talking about the individual divisors.
Uh-huh.
Individual divisors. I'm talking about the general common divisors. I mean, the 2 can divide 8 and 12. 4 divide
Yes.
and 4 can divide 8 and 12. But the highest one is 4. Highest one is 4. The highest common factor is about finding the highest common divisor. Okay? So for example, you can write the highest common factor, or you can begin with begin this with G, greatest common factor of 12 and 8 is equal to 4. Do you understand this?
Yes.
But here we will use the lowest common multiple of the degrees. Okay? Just you have to find the lowest common multiple of the degrees. After that, what you will do, just change them. For example, so 4, just we need to divide 12 by 3. Now 12 by 3, you have to divide the lowest common multiple by 3, and you will get 4, right? And multiply this here, put this here. I mean the exponents, make the exponents under the root. Okay, you have, after that you have this 3 multiply 4, 7 power 4. You understand? Now 12, 7 power 4. When it comes to 6, you can do the same as well. You have, 12 divided by 4 is equal to 3. And it means you have to multiply 4 by 3. And here you have to put this one, remainder. Okay, and I mean the results. Because you can, anyway, you can drop them. You can drop them. You can erase them. 3, 3. It's okay.
Uh-huh.
Do you understand?
Yes.
Here you're finding the common roots, and using the third law 1. Third law 1. It's about, You can find this law about this. For example, you have n, so b, yeah, and you can multiply the degree by the same number and is in the radicand as well. So this is a, okay. This is formula. Here you can see. So can you solve this one? Oh, this is already solved. This is example how you can make the degrees the same, and you can see here, and you got the solution. Do you understand how to make the degrees the same?
Mm-hmm.
All right, let's go to the next. And look at this problem and solution. So you may be given such kind of problems that contains the surds. And here you have to use the laws of the surds. Laws of the surds. For example, the first problem can be solved in this way. For example, you taking the common multiple out of the brackets, you know. So this one is common multiple, common. You can see under square root 3, under square root 3 in each multiplication. You can take this common multiple from the box, you know, and you will get this expression. Do you understand?
Uh-huh.
And here the same also. The surds are the same. Under cube roots, you have 5. You have 5 here, and you taking this common multiple out of the box. Okay. But here, another situation, because they are the radicands are not the same. In this case, you can, use prime factorization. I have explained the prime factorization, right? Prime fact in my first lesson. Prime factorization, it looks like this. For example, you can divide this 8 into its prime factors, its prime divisors, you know? So 2, 4, 2, 2, 2, 1. This operation is called prime factorization. And you can make the prime factorization here. For example, you can begin with 3 and finish with 5. This the factorization of 75. Do you understand?
Mm-hmm.
And then the second one can be factorized in this way. You have 4 2's. It means the power is equal to 4, and 1 3 as well. And here you have 5 3's. It means, the degree of this root is equal to 2. It means you can decrease the power 2 times. Here, for example, you have how many 3's?
5.
5. And you can write this in this way. 3 multiply 3 power 4. You know? You left this. Why? Because if you add them, it becomes the odd number. Odd number cannot be divisible to even number, you know? And after that, you can take the square root of the 3 power 4, but you left 3. That's why you got this one. Do you understand?
Uh-huh.
The same goes with this always. Them always. And all the and you will get this kind of common multiple here. And you taking out of the box, and you can see this expression finally. Do you understand? Here also the prime factorization, use it, prime factorization, and you're taking the, real numbers out of the square, out of the roots, and you lefting the unrootable numbers under the roots. Do you understand? And then you take the common multiple here, and you got this expression. Okay. And one more crucial thing about this kind of third problems is about using the formulas of the algebra. This kind of formulas, a minus b, a square minus b square equal to a plus b multiply a minus b. You remember?
Yes.
And also a plus b square equal to a square plus 2ab plus b squared. We are going to use such kind of expressions here. For example, you are given this problem. Look at this. This is mixed surd, right? This is mixed surd.
Yeah.
And here you have to multiply its pair. When you look at this one, I mean the 5 square root minus 3. Its pair is this one. So multiply plus 3. You understand? Plus 3. Because you are going to use this expression, algebraic expression. You have a addition, you have a subtraction. Okay, here. That's why the problem is multiplying its pair to both sides to keep the rule of the fractions. And what you will have is this one. Simplifying it, and finally you will get this. Do you understand this?
Mm-hmm.
Here also the same, I mean, this one is used. You multiplying the 7 and its pair to the numerator to the denominator, and you will get the squares of each third, and it becomes 3 and 2, and you can freely minus them, and you will get 1. That's why you can drop the denominator, and you will get this one. So this is also another way of explain. So it's getting rid of the root from the denominator. Do you understand?
Yeah.
Okay, let's go to the problem solving. So your tasks, the first, the second, and also this one. I'm gonna give you just 5 minutes to solve these 3 problems, okay? And then
Yes.
I will ask you your solution. Now time is going. Okay, you finish?
Only last one I couldn't do.
Only last one you couldn't do. Okay,
Yes.
so let's deal with this problem. As I explained before, you can use algebraic formulas for this kind of fractions. Okay, so now let's analyze this formula. A square minus b square equal to a plus b and a minus b. Here, if you look at this, a square is 9, b square is uh, no, it's not the square, just anyway, because we need only, so here, look at this, 9 equal to a plus, and 2 square root under 14. We have this one, but we don't have what? This pair, the minus, which is a equal to 9 and b equal to 2 square root 14. Yes, and middle you have to put minus. After that you will get this one. I mean the 9 square minus this one b. So this one is b, to multiply on the square, 2 multiply on the square root 14. This is the square. Okay.
Mm-hmm.
So my writing is some kind of unclear. That's why I'm gonna write it another way. 9 square minus, so 2 multiply 14 square. You understand?
Yes.
So for this algebraic fraction, you have to multiply this pair to the both sides. Yeah. So if you multiply them, you will get this one. So I explain the simplification of this. That's why I'm going to write it here. So 9 plus 14. So 9 minus 2 on the square roots. You have 4. And you have to multiply this expression to the numerator as well. 9 minus 2 14. Okay. And as you simplify this, this is a final result of these two expression. If you simplify this, you can find the denominator, right? So 18 minus the square of 2 is 4. The square of the square root is equal to the radicand, you know? You understand why I'm omitting, dropping the square root? Because
Yeah.
if you multiply, if you take the exponent of the square root, if the exponent equal to the degree, and then you can drop the roots. This is 14. Okay, 14 and 18 minus, so this one,
56.
yeah, 56. So this is 56. I think it's my negative number. So minus, so you have to subtract them. Okay. So now you understood this, right? So here the value is 38. And how are you going to simplify this one? You know, if you solve these two problems, you can simplify this as well, you know, because you have to multiply, you have to multiply each bracket with its relevant components, you know. If you open the bracket, you have to multiply each component of the first bracket to each component of the second bracket, you know. So
Okay.
do you remember this? Algebraic. This is algebraic simplification, and here I'm multiplying this third to 9 and under square root 7 multiply 9, and here and the second one is minus, this one is minus, that's why I'm multiplying the 7 multiply 2 by 14. Okay, so and then let's go to the second component, which is under square root 2. I have to multiply the square root 2 by 9, and then this one. Okay.
Where is square root? When like in 7.
Yeah. No, I drop it, so I forgot about to put the square root here, and also you here if you multiply so under square root by 9, it's positive number, right? It's
Yes.
positive number, and then this one is minus, so 9 multiply, let's erase this one because we don't need it, so in its space 9 multiply, so under square root 2 multiply under square root 14. Yep. And let's simplify them. So if you multiply this one, you know, you can multiply this both of them, you know. So, but you can't multiply this one because you have subtraction between these pairs, you know. 9. So 7 on the square minus 2 multiply, you can take the common root, and the 7 multiply 14. Okay, so
excuse me.
okay, question.
Why you put 9 there? Uh,
In front of the third.
no, it's upper. It's
Upper.
right. Right, yeah.
On the right here.
Yes.
I'm continuing it. I'm continuing it. You know, this is a continuation of this one. Why? Because so here actually it is so this is a 2, this multiplying being multiplied here, this is being multiplied here. Actually it should be 2, it's not a 9, it should be 2. Okay, because when you multiply to this it should be 2. Okay,
Yeah.
now you understood, and let's continue. So here you multiplying this one, and this one, but you can change it, change this, the third term to multiply 9. Okay? Minus, you can multiply these thirds each other because their degree is the same. Okay, so multiply on the square root to multiply 14. So, and let's simplify that. You know, the 14 is the 2 multiply 7, you know?
Yeah.
That's why you can, that's why you have 2 sevens under the square root. It means you can take the 7 out of the root. You can take the 7 out of the root. So minus 2 multiply 7 square root, you have 2. Okay, and this one plus, so 2 multiply 9, and then this one, you know, the 14 is the multiplication of 2 and 7. That's why you have 2 2's under the square root. It means you can take the 2 out of the roots. Okay, so, and what you will have under the square root is 7. Is 7. Now I'm gonna erase them because we don't need anymore. And so after that, you have this expression that is 9 on the square root 7 minus 14, and repeating this one, 14 on the square root 2 plus here on the square root 2 multiply 9, so 9 multiply square root 2, here minus 4 on the square root 7. Yeah, so look at this. This term has on the square root 7. This term has on the square root 7. It means you can pair them, right? So minus 4, 7. And look at this. So this one has minus, this one has on the square root 2. This one also has the same. That is what, and that's why you can pair them. So 9 square root 2 is the multiplication, and minus 14 square root 2. Okay. take the common multiples out of the bracket. If you take out of the brackets, you will have what? 9 minus 4 and so this I need the space. I have to erase this one as well. And here you taking out of the bracket plus in this one minus 2 multiply 9 minus 14 again. And here it is 5, right? It is 5 under square root 7. So here this is this negative number, you know, this bracket is negative number because you're subtracting 9 by 14.
Yeah.
That's why you have to put minus here, and this is the result is 5 and minus and under square root 2. As you can see here, these two terms has also the common multiple 5, right? It means you can take out of the brackets, and what you will have is the 7 under square root minus under square root 2. This is your results, and you can write your answer here. So 5 under square root 7 minus 2. Okay, you understand? So, and let's your previous problems, I mean the first and the fourth, should be solved in this way. Okay, note that should be solved in this way because you have to multiply each term. You know, this is algebraic expression. It has two terms. This each expression is called term. Okay, and it has two terms. If you multiply two brackets each other, you have to multiply the first bracket's term to each terms of the second bracket, like I did. For example, here you have to multiply this one to this one to this, and when it comes to second, you have to multiply this one to first, and this one to first, like I did in this expression. Do you understand? The rest of the problems remains as your homework. Okay, as your homework, you have to finish these all of them. If you have any raised questions, feel free to ask me. I'm in the Telegram to help you. Now I'm going to explain you a platform, which is this one. This platform has different kind of topics. For example, operations, the number systems, whole numbers, integers, as you can see here. The link is in this one. This is Siavula platform. It is technology-powered learning. Okay, here you have math problems, a lot of math contents. Okay, so just I'm gonna go to this website. Can you see my screen?
Yeah.
Here you can see different kind of topics, exponents, for example, exponent laws, for example, you can see here, and exponent laws, square roots, cube roots, you know, you need this kind of problems a lot to, you know. So what do exponents always tell you? For example, you can what the exponents always tell you, how long until sunset, which calculation to do the first, you know. You can check, as you can also find this kind of problems in the Facebook, WhatsApp as well, you know. Here we have also Surds. Here we have also Surds, rational exponents and the Surds, you know. You have this kind of Surds as well, you know. So simplify the surd below without using calculator. How can you simplify it? Well, because 14 is what? Is you know, 4 multiply 10, you know?
Yeah.
4 multiply 10. 4 is the square of 2, which means you can take the square root of 4, but 10 remains under the bracket. Do you understand? Okay. You have many problems like this in this website. You can find it. You can make extra practice, you know. So it's free website. You can find this kind of problems for free. You know, you have all the topics that we have to cover: geometry, you know, statistics, probability. You can make a lot of practice. So let's go our slides. By the way, this is your textbook. This is your textbook. Here you have to read the you have to read Surds topic, you know. Surds topic, and their explanations provided. For example, third law. You have to read all of them. I have already sent it to you. This book is called Everything Math Grade 11. Okay. So you can use rationalizing denominators, you know. At the end of this book, you have these problems. This is also a part of your home task. You have to finish them, all right? You have explanatory videos and solutions as well. You can find them. Understand?
Yeah.
And so write down your home task. You have to register for the platform and solve search problems on this platform. Okay.
How it's named? Platform? So
This one. So this one. I will send this link to you. It's not a problem. Okay. This is Siavula. And the second task is presentation problem. Here in the presentation, we have other problems as well. Do you see? We didn't solve 10, 9, 7, etc. We solved only 3 of these problems. And then the third one is your textbook problems. I assigned you the textbook problems, yes. At the end of the book, you have a set of problems. Okay.
Textbook problems. Where is it?
This textbook problems. I will explain it right now. I will send it to you. I've already sent it to you, by the way. but I will resend you, okay?
Okay.
If you don't find it. So, and this is the end of our lesson. If you have any questions about today's topic, feel free to ask.
Okay.
The more problems you solve, the better you develop, you know? The better you understand the mathematics. Okay. Thank you for your attention. See you next time. If you don't have any questions, let's finish this lesson.
Okay. Thank you.
Thank you. Goodbye.
Goodbye.